Okay, so here we are on the Exploring Waves student copy. Did question one together yesterday. I'm not going to do questions for you, but I do want to review what you need to be doing for anybody who needs that co-teacher to kind of step in and help you out. So for question two, if you observe closely, you'll notice the particles leave a trail behind them as they move. The longer the trail, the faster that particle is moving. During any up-down cycle, the particle doesn't move at a constant speed or with a change in speed. If the speed is changing, at what point during its motion does it move with the greatest speed, the smallest speed? Discuss fully. You are working with your lab groups. So we'll go ahead and take a look here. It's talking about this little trail you see dragged behind it. I'm going to run it in slow motion just because you can see then the trail isn't actually there at all. So I did that on purpose. You have to watch it in real time to see this trail happening. And so you can see the trail behind the dot. It's talking about that. Remember, you want to be at roughly 0.100 hertz, wave speed of 100 centimeters squared, and an amplitude of 2 centimeters. We're watching in real time. We are looking at a rope. So your screen should look just like this when you're doing this part of the lab activity. So you'll answer here based on how it's moving, where it's moving, what things you find there. There are a variety of ways to categorize waves. One way is to categorize waves as being transverse and longitudinal on a surface. Waves in each of these categories differ from one another in terms of how the direction of the particle motion compares to the direction of the wave motion. Waves traveling through the rope are transverse waves. For transverse waves, compare the direction that the particles move to the direction that the waves move. So it's just talking about transverse waves, how they move. This is a transverse wave. How does the wave move? How do the particles move? The wave is the green, it's the piece of rope. The particles are the red, the little dots. That's all I'm going to say on that. Okay. Now use the frequency slider to increase the frequency to a high value. Compare the motion of the particles when the frequency is high to the low frequency motion. How would you describe the difference? So you're just taking your frequency meter and going to something high. Okay. How does it compare? Next step is going to take some skill and some careful observation. The wave speed is associated with the movement of crests and troughs along the medium. Faster waves will have crests that move from the left side of the screen to the right side of the screen in less time. That is, the crests move from the left to the right faster. Set the animation to a low frequency, back to about 1 hertz, 0.1 hertz, and observe the wave speed. It might help if you put your finger or a pen cap on a crest to follow, move your finger or pen cap from left to right along with crest. Then repeat for a high frequency, about 1.0. Make the same observation of wave speed, the speed of the crest moving from left to right across the screen. Does this tenfold increase in frequency have any noticeable and appreciable effect upon the wave speed? Explain and discuss your observations. So we're going to do the frequency back down to roughly 0.01. I got 0.099, that's fine. So you're supposed to put your finger on one of those crests, then change it almost all the way up. Put your finger on a crest. How does it move? How does it differ? How does the wave speed change? Okay, so answer your question there. Does moving the frequency slider from low to high change the listed wave speed in this animation? Yes or no? Change the wave amplitude from a high to a low value in terms of particle motion. How would you describe the difference between a high amplitude wave and a low amplitude wave? So changing the amplitude, it's very high here. Now it's very low. How does that change the particle motion? Okay. Wavelength of a wave refers to the length of the repeating pattern of crests and troughs. Long wavelength waves have crests that are spaced relatively far apart. Short wavelength waves have crests that are relatively close to each other. Use the controls to determine 2 ways to increase the wavelength of the waves. Describe what you did to increase the wavelength. Can't do that one for you. You got to figure it out. Okay, now we're going to change it to sound. So I'm going to go ahead and just do that first. Show wave as sound. And we are going to be going back to that 0.10, 100, and 2. So okay, that's our setting. Same as we did before, except now we're on sound wave. Observe the motion of the three colored air particles. Describe the motion of these particles for a sound wave moving through air. Okay, 1, 2, and actually it looks like, yep, so it says 3. We're only seeing 2. Got to kind of make your observations based on that. Use the frequency slider to observe the effect of frequency upon the motion of the particles in the medium. How does the particle motion differ for a higher frequency wave compared to a low frequency wave? You know how to do that now. We just did some frequency stuff. Sound waves traveling through air are a type of wave known as longitudinal. The longitudinal waves compare the direction that the particles move to the direction that the wave moves. Okay, your assessment is actually on a Google form. It's already been added to your Google Classroom page. Looks like this: Exploring Waves Lab Assessment. Okay, as a transverse wave travels through a rope from left to right, the parts of the rope are, answer your question, for transverse wave, the particles in the medium move blank to the direction that the wave moves. Longitudinal wave, the particles in the medium move blank to the direction the wave moves. The frequency of a wave describes. Increasing the frequency with which the particles within a rope vibrate causes the speed of the wave to. Amplitude of the wave describes. Increasing amplitude will cause the speed of the waves to. Wavelength of a wave increases if the blank. Select 2 answers. That is what you got going on today. Like I said, this last part's on a Google form. Please do make sure to turn in. I don't have turn in, I have comment. Make sure to turn in your Exploring Waves lab so you can get credit for it. If you do finish that early, as I mentioned during the intro, then you can go ahead and make sure you've done your easy quiz and gotten it turned in. If you get that done, make sure you've got your notes from Edpuzzle done. If you get all of that done, then there's going to be a study guide posted for the quiz that's coming up a week from Tuesday. It's going to be on October 29th. So that is everything going on for today. This is your co-teacher vlog on the Exploring Waves Lab. Hopefully you were able to get all your work done, and I'm going to go ahead and hit stop sharing.